Hey guys, welcome back to our next video in our data science interview question series. So let's begin with the next question. It talks about data modeling and database design. So I'll just write here first. This is going to be data modeling, and then there would be a database design, which is actually a process. So when it comes to data modeling, it's basically does not has any sort of implementation. This is the first thing you need to remember. There is no implementation. It's all about getting an idea how exactly this is going to be. The next thing is this is based on relationship between data models. I'll just write there are different data models, and based on that, what exactly is going to be the relationship between different types of data. This is going to be actually take place. Then there is also a systematic data modeling techniques used in this kind of method. Data modeling techniques are used here in order to decide what exactly is going to be the structure of the data. Without any implementation, this is actually getting an idea how the interlinkages take place. And there are common methods also involved. So it is based on data entity data relation diagram, or you can say entity relation diagram. I'll just correct this. We also have unified modeling language, basically called UML in this case. Okay, so basically these are two types of class diagrams we use when it comes to data modeling. Don't worry about these things, and we will tackle this in the complete one question, which will be coming up next. So in order to understand what exactly these type of diagrams are, and I'll just erase this. All right, now let's understand what exactly database design is as compared to data modeling. So it is basically a process of designing the database. Designing, okay. So we decide how exactly the database is going to be, what could be the best method of getting the data and reducing the redundancy in that and getting exactly. So normalization is one of the technique for data redundancy here, and I'll just write normalization for data redundancy and minimizing your data dependency also. Okay, then there is also a practical aspect involved here. It's not like there is no implementation. This practical aspect also involved for organizing the data, and it also involves storage choices, where exactly the data is going to store those things. And I can also say physical design is also involved in this step. All right, so just to summarize what exactly it means, that data modeling is just your implementation and deciding what is going to be the relationship between different type of data models, and that is decided based on your systematic modeling techniques, which is ERD and UML diagram. And database designing is a practical aspect where we actually decide how we are going to store the data. Then implementation is also take place, and we minimize the data redundancy and data dependency in this process. Okay, so one is the process, another one is just having an idea and no implementation. All right, let's move to the next one. This one is about feature vectors. So when I talk about feature vectors, suppose there is n dimension, then what will happen is your numerical feature in n dimension represent the object. Okay, so suppose there is some object and it has n dimensions, then there would be n numerical feature representing that object. Okay, that is what the mathematical term is about. Let's understand it via diagram. So suppose this is an image, and since it's an image, it will involve pixel. Okay, so suppose n pixel image is there. Now my objective is to create a feature vector from it. So from our example, this is actually an object for us. Now I'll just go further deep down into it and try to understand what does this image comprised of. So this image will have your intensity, and what else it will have? So it will have your color. That color scheme could be RGB color scheme, the attributes is involved. So for right now, let's suppose these two things are there. So what I am going to do, I am going to combine them to get vector from it. So I'm using these attributes and I'm getting a vector from this. What next would be happen? I will use this information into my ML model. And when I put this information into my machine learning model, then I am going to produce something for image recognition or data pattern. So this is what exactly your feature vector looks like. How exactly we go through the process. Okay, and there is also a concept of feature space in feature vector only. So what does this means? It means vector space associated with feature vectors. So whatever the space is going to associated with the feature vectors, that is what exactly is your feature space. This should be all right. Yeah, I think that is for this one. Let's move to the next one. All right, so the next one is about ERD and UML. So I'll just write ERD here and I'll write UML here. Now both ERD and UML are class diagrams. So when I say class diagrams, it means they have an entity and then they have a relationship between the entity and then they have the attribute of that entity. I'll explain what exactly I mean by entity, but just to understand this, so this one is primarily used in data modeling. So I'll write data modeling and in bracket I'll write usage. Similarly, this one, when it comes to, it is basically used in software engineering for documentation. So I'll write system documentation. So all type of documentation work we use UML diagrams, and I'll just write usage here. Okay, so we are clear with usage. Now we understand both of them are class diagrams, and when I say class diagram, it means there is an entity involved. Then these these diagrams also consider the relationship between the entities. So both of them have some entities, and then they have a relationship between those entities, and then they have attribute of the entities also. So since we both of them will revolve around entities, let's understand how this will look like. So this will have rectangle, and those rectangle are basically the entity, and those rectangles are the main points. Okay, those are the pillar of the diagram, I can say. Then there will be oval, and these ovals will be connected to the entities, and they represent the descriptive properties of the entities. So basically the relationship, they represent that. So I'll write descriptive property of entity. And then comes the lines. So lines are basically showing the relationship for different entities with each other. So just to give an example of an ERD diagram, it would be good to say it contains university database. So I'll just write example here. Yeah. So the example would be university database, and in database I can say student as an entity, or we can also say teacher as an entity, but let's take student right now. Student as an entity, and then their enrollment as the your attribute. So I can say attribute, and then there would be lines which show the relationship between student and their enrollment. Okay, let's understand UML also. So in UML, let's say there is a use case. There is a use case diagram. So what does this will depict? This will depict relationship between system and its user. So how exactly a system or a platform is there, and how user are interacting with it. So how exactly you are interacting with the interface of YouTube. That will also be an example of use case. How exactly you are going to use different option. Then another, I can see there is a sequence diagram. So I'll just write sequence, yes, sequence diagram, and it shows over time how the interaction has been. So how objects interact over time. So how exactly I can say people are using my YouTube channel over time, what has been the usage. That is what exactly this type of diagram shows. Then I can also say there is an activity diagram in UML. So by the name it is clear it is going to talk about the activity only. So it says flow of activity within a system. How exactly the flow of activities are taking place within a system, that is what it actually shows. So with this you understand how exactly ERD and UML diagrams are used in data science. So yeah, uh, I think that is all for this video. We will create a new videos of questions in the playlist. So I see you next time. Thanks.